Hi, fear not this problem. Whether this is your first time or your fifth time reversing a linked list, my goal in this video is to give you a simple and easy pattern that you can easily remember how to implement. So let's take this list and learn how to reverse it. Here we go. To solve this problem, we'll need exactly four variables. Let's go through each variable to understand how we can use them to reverse the list. The first one is called current, and essentially all it is we're renaming head to current. So we can get rid of this head. And the next one is previous. Previous is going to be the node object before the first node object, but there is no node object, so we just assign it the value null. Okay, the next one is a property of current. So current has two properties, current.val, which is 1, and current.next, which is a pointer to the next node object. Okay, so that is going to go to the first node, and it's going to point to the second node objects, which contains two properties, the .val, which is 2, and the pointer to the next node object. And the last variable is next. Next is going to be a reference to current.next. We're going to use it after we update current.next so that we can find the second node. Okay, so we basically have our full algorithm written out here. Now we just need a way to go through the linked list and update each one of these properties so that we can reverse the linked list. That means we need a loop. In this case, we're going to use a while loop, and we need to check for a specific condition. Okay, so what condition are we going to check for? We are going to check if current is null or not. So if current is not null, we keep going, keep going, keep going, keep going. And then when we finally reach null, we stop. While current, what are we going to do? The order of operations is very important here. So let's see what we do first. The first thing we want to do is update current.next. And by doing that, we're going to change the order of the list. This is the most important step. So current.next will be set to the node before it, which is previous. Just like this, we move it over and we're done. We reverse the list, but don't forget about this. This blue and this red arrow are actually the same. So let's just update that. There we go. And the next step, so let's bring this down here. There we go. We created next already, and we updated current.next to be previous. So the next step is going to be to set previous equal to current because we want to go through the list. So we need to move down towards the right. Finally, we update current to be next. And that's really why this reference to the next node object is so important. We need this next variable. Okay, and when we do that, it implicitly will update current.next because current.next is a property of current, and that also brings this to the next, it starts pointing to the next node object. All right, so we have previous here, and we're ready to start on the next loop through the entire algorithm. Okay, let's move pretty quick now. So the first thing we're going to do is set next equal to current.next. That creates a reference to this node object. Then we update current.next to previous. Boom. Then we update this arrow too. Let's not forget about that. All right. Then we move next, or then we move previous to the next node, and we move current to the next node. Awesome. There we go. And that implicitly will update current.next just like that. And we can start again. Next equals current.next. Okay. Current.next equals previous. Awesome. And let's update that pointer. Awesome. Update the pointer to the previous. Previous equals current. Current equals next. Awesome. There we go. And now we need to update current.next. Here we go. And that points to the fifth node. Finally, we assign, or first we assign next to current.next. Then we assign current.next to previous. There we go. Previous to current. Don't forget to update the pointer. Awesome. And current is going to equal to next. Great. Current.next implicitly points to null. And we set next equal to current.next. Awesome. Current.next switches and points to the previous node. and previous gets set to current, current gets set to next, and current.next implicitly moves, and implicitly now it's pointing at null, and we don't forget to update the last pointer. And now, as you can see, previous is the new head of the node. That's really important because we're going to return that below our loop. Okay, let's code it out. We're going to declare two variables outside the loop. Those are current, and we're just renaming head to current, and previous. Okay, if I could spell that right. Previous is going to equal null because there are no node objects before this first one or head. And we're going to keep looping while current is true and not a null value. So there's 4 steps we need to do inside of the loop. The first one is we need to create our variable next, and that's going to be set to current.next. So we can always have a reference to that next node object even after we update current.next, which is going to be the next step. And the trick to this algorithm is we can always use the end of the current line as the start to the next line. So current.next is going to be set to the value before this, our current node, which is previous, and that will reverse it. And then we just copy paste this because the end of the current line is the start of the next line. Previous is going to be set to current, and that will move it down the linked list so we can iterate through the list. And then we copy the end of the line, paste it to the next line, that's the beginning. Okay, and then current is going to be set as that reference to the next node object. So thank you to next, we have that value that we can use to find the next node. And then the last thing is what do we return? Remember here, previous becomes the new head, so we just return the head, which is called previous. Now let's run it. There we go, passes, and let's submit it. Awesome. Congratulations. If you have any questions, let me know in the comments.